Okay, here's the situation for number 13. This will be our final problem for the day. Okay, we have two objects initially the same height above the ground. Simultaneously, one is released from rest. That's going to be this guy. We'll call this guy object 2. This guy will be object 1. So this guy just gets dropped, right? This guy just goes straight down like that. Okay, but simultaneously, this other object is shot off horizontally with an initial speed of 2.5. So this guy's going to go like this. Look, this guy's going to go pew, like parabolic, and then the two objects, bam, they collide right there. So let's see, the two objects collide after falling 20 meters, right? So they both start here, they're both starting there, and they both collide with each other right there. So this is our y displacement. So what's the y displacement? 20 meters negative. Why negative? Because it goes down. Okay. So again, what do we know about x velocity? This x velocity, so ball number one started with an x velocity of 2.5. So what's the x velocity here? 2.5, right? What would be the x velocity here? 2.5. The x velocity stays constant, but the y velocity is getting bigger, right? For both of them. So here are the steps. This is a two-step problem. So for both objects, we know that the x acceleration is 0, and then the y acceleration is gravity, which is negative 9.8. So this is true for both objects, okay, those accelerations. Now, how about this? Is this true for both objects? The negative 20? So both objects start up here. The problem's over here. Do both objects fall 20 meters? Yeah. So looking at ball number one, what's the initial y velocity? 0. Right? Because how does ball number one start? Only with x. So here's step one. Step one, find time for two balls to collide. Okay? And we're going to use the y direction. So here's what we do. We go y equals 1/2 gt squared plus vy initial t. Look, for both balls, what's vy initial? Does ball number 2 start with a y velocity? No. It does. Ball number 2 has no y velocity and no x velocity initial. Does ball number 1 start with a y velocity? No, at x velocity. So we can cross this to 0, right? So now we have this. We're left with this. So t is going to be square root 2y over g. That's going to be 2 times negative 20 over negative 9.8. So this gives us a time of 2.02 seconds. So look, that's the time it takes to fall 20 meters, starting with no y velocity initial. Right? That's how much time it takes for an object to fall 20 meters. So now what we do is we go, okay, step 2, find how far ball number 1 travels. How do you spell travels? 1 L or 2? Travels in x direction before the collision. How far does ball number 1 travel in the x direction before the collision? So ball number 1, look, starts right here. Here's where ball 1 starts. Here's where ball 1 ends. Can we solve for this x distance here? Yeah, what's the only equation for the x direction? Vxt. What's the x velocity of the ball? 2.5. how much time does it take for ball 1 to reach ball 2? 2.02 seconds. The seconds cancel. 5 meters. So how far apart were the two balls originally? 5 meters.